Good stuff. So hi everybody, I'm Dale from Hashicorp. Sounds like most people know the company. Does anybody not know Hashicorp? No? Okay, cool. That's good. Well, thanks for inviting us in today. So we've obviously spent some time with your team around some of the tool sets that you use. So we're an open source company. We've been open source for 5 years. And a lot of people know our individual tool sets. But Hashicorp as a brand is sort of getting out there, and we play in this category of cloud infrastructure automation. And so if you pick up a Gartner report and you look up for cloud infrastructure automation, you'll probably find Hashicorp under there. In broad strokes, what we're helping customers do is the application layer has been pretty flexible up till now, but the infrastructure hasn't. And so we are helping customers who are making this transition from monolithic applications to microservices and breaking down their application estate, but then also moving and taking advantage of cloud, also automating more on-prem and getting yourself ready for that cloud. And I think your Terrible product already does that to some extent, but also there's additional features that we bring to bear. So this year we've had about 24 million downloads of our products across the range. So there's broad scale adoption of the open source products. We're going to do a demo. So the slides are going to be pretty low key. But what I wanted to get across is the way that Hashicorp thinks about designing the products, the philosophy behind the company, because I think it's quite important to understand. A lot of people will bring out, or a lot of companies will bring out a technical product and then try and sort of sell you that and sort of wedge that in. We look at workflows over technology. So what is the workflow? Bearing in mind this company was set up by two practitioners, Armand and Mitchell. They were wanting to deploy workloads in an efficient way, but also take advantage of the cloud. And they saw gaps in the market as to what is the workflow that you need to achieve to get these applications and infrastructure out into the cloud. And so the workflow is the sort of typical application delivery lifecycle. You write an application, you don't get away from that piece. You hopefully test or QA that application. Once you've tested and QA that, you package the application up. You then want a way to provision that application to your infrastructure, run it efficiently, and then monitor that. So monitoring comes in various sort of guises, but essentially those are the 6 elements, and then security is at the heart of that. And how do you make sure that all of these steps that you're doing is secure? It's not something that you can sort of bolt onto the end. So with that lens of what is the workflow we're trying to satisfy, we have built, I won't go into all of the products now, but we have built products into all of these areas that help with that life cycle. I guess important to understand this is not a platform. You don't have to buy into the whole Hashicorp platform to get this. We sort of follow the Unix philosophy here. We will build a tool to do a simple job. So for example, if it's on the run side and you need a scheduler, there's Nomad to do that. If you had existing tools in your environment that you needed to integrate into, Hashicorp can do that. So all the interfacing is done through APIs, even through our own products. There's no secret source. All of it's through API integration. So if you, for example, wanted some of the products, but you already had your own security service in play, you could do that. So I think it's good to kind of just level set in terms of we look at that workflow and making sure that you're achieving that. Infrastructure as code, I think everybody's on board with that. If we have infrastructure as code, it's easy to write it, it's easy to version, it's easy to roll back, and easy to scale, right? If you're going from on-prem to cloud, you're probably managing thousands and thousands of instances. The only way to do that really is through code. And then everybody, just to set the scene, is making this shift. This is what we've seen across any industry. Everybody's racing to go digital, whether it's in banking or your own sector, which essentially means you need to open up more of your data to your client base or to your third parties, which is putting more constraints in your own infrastructure. So people are making the shift. You guys probably made that to AWS sometime, but are going multi-cloud. So I specifically deal in a lot of financial services companies. They're at least picking 2 clouds. AWS was first. I know your Finnish counterparts are using Azure, GCP, etc. And so we're looking for a consistent way that you can provision across that. That's what Hashicorp gives you, a consistent workflow across all of those clouds. Suffice to say that all these big cloud vendors are behind us. Azure have 15 dedicated staff working on Terraform integrations. AWS have about 10 or 11, and GCP have about 7 or 8 people. So it's a big vote of confidence from those cloud vendors that we have the tools to help customers get there, because ultimately the cloud vendors don't care how you get there. They charge on a consumption-based model. And so we help you firstly provision across that. Once you provision across a multi-cloud environment, you have a security issue. So you need to think about security in a different way. You need to sort of say that all of these networks are zero trust. And so how do I secure across my applications across that landscape? Making sure that you can connect up to all of those. And I think an essential element here is to understand that we don't take away the cloud, the native cloud functions, for example. So I see some people going to GCP for machine learning and AI and the analytical workloads that they're good at, and they'll use another cloud for other workloads. So you can think of Hashicorp as almost that English language, right? You can talk English in any country you go to, pretty much. But when you're there, for example, here in the Netherlands, you want to take advantage of the local cuisine, the good beer, and the food, etc. So Hashicorp will get you to that destination, but also make sure that you're making use of the native cloud functionality there. And so this is a lens of our sort of products and how we see the challenge. So on the left-hand side, you basically have 3 core groups. You have the operations team, the provision infrastructure. You have the security team that want to secure those workloads or the infrastructure. And then you have the development team that are coming in and making use of the applications and the infrastructure. And so a lot of people are moving to DevOps and secure DevOps. A lot of big customers can't. And so our tools make sure that these teams can work in a collaborative way, but there's still separation of duty in terms of who owns what. And so we see this as the sort of the blueprint in terms of if you're moving from your own internal data center to a cloud-based model, you need a consistent way to provision. Once you provision, make that secure. Make sure that your application is then running efficiently on what you've secured. And then the last piece is the ping piece, which is console, making sure that all of that is connected up together. And so that's just sort of a level setting in terms of what's happening at Hashicorp, what we're seeing in the market, and then the sort of the products that we have. So over to Chad to do the demo.
Great. So just to level set, are we looking to end by 10 after or earlier? Ish?
We started earlier, so you can.
No, I can. Whatever time frame is good. Another half an hour? Okay, I'll probably be faster than that. Because there's beer, everybody's kind of checked out. If this thing doesn't attack me. This feels really weird to wear. I hope it doesn't look as weird as it feels. If it does, you're welcome. You get to look at that for half an hour. So how many people in the room? I know there's a lot of people that are remote, so sorry, you'll kind of be counted out for this. But I'm going to go back to this slide, and then I'll get right into the demo. But how many people in the room here, which is really heavy on this side of the room? I have to stay over here just to hold it down. How many of you have actually heard of, before today, how many people had heard of Vagrant? Okay. How many people had heard of Packer? Okay. Terraform, Vault, Console, and Nomad. That's a no. No, I'm just kidding. I was sort of the same way. So I joined Hashicorp. My name's Chad Armitstead. I joined Hashicorp in June of 2017. Before I joined, I pretty much knew about Packer. I had used Terraform pretty extensively. I knew of Console. I, of course, had used Vagrant. It's kind of hard not to if you work in ops or dev anywhere. But I honestly had no idea that all of them belonged to HashiCorp just because I never had reason to look that up. I just looked up the documentation for the tools, and the branding is, I guess, relatively new. So it was sort of a surprise or pleasant surprise to me that all these tools sort of resided in one place. Just before I dive into the demo, I wanted to talk about this slide just a little bit. How many of you have heard of HashiCorp's Atlas? That is a branding win right there. Atlas is kind of no more. It still exists, but it's different. It was, and I'll go into what it is. How many of you have heard of Auto? Okay, Auto. We don't talk about Auto anymore. But Atlas was essentially a combination of a lot of our tools. It was a SaaS offering. It still exists. You can still consume Terraform Enterprise via atlas.hashicorp.com. And what we found really quickly, and if this is recorded and the founders are seeing this, I'm sorry, I'm going to butcher your stories just a little bit. But so Mitchell Hashimoto and Armand Dadgar founded the company. They also built a lot of the products like Vagrant. But as soon as we put all of these products, and I think that initially, I'm not even going to venture a guess, but I'm pretty sure that we offered Terraform, Vault, Packer, and Vagrant as sort of a platform. I believe Console may have been there. I never used it actually when we were selling it as a full platform. But as soon as we put it into a platform, we sort of realized, oh yeah, that's really great, but we need a custom monitoring solution here, and we need another testing framework here. And we realized as soon as you build a platform and try to, give it to someone as an entire platform, they're going to need something that's unique to their sort of use case. So we went back to the Unix philosophy. We never really departed from it with the individual tools, but we just thought, you know what, we're going to issue each of the products as their own thing, as one tool that does one thing in a very defined space really well. So a lot of this may be sort of not new to some of you. I am going to show enterprise versions of the product. I also was an engineer, a systems engineer for a long time, systems architect. I too was very devoted to open source. It's okay to look at enterprise products sometimes, just relax, it's all right. Nobody's gonna make you buy stuff. But it is a really nice, it is actually a nice illustration of the workflows, and talking with your teams today, actually you've run across a lot of the similar sort of workflows. So it might be some food for thought around just how you're achieving what it is that you're achieving, and a look at sort of what other workflows people are running into that use these tools. So let's close this. Okay. So first, this is what Terraform Enterprise looks like today. So, looks like mountains. Let me mirror my displays real quick. Okay. Okay, so for the demo, because a lot of you are fairly familiar with Terraform, I'm not going to focus a lot on the code, but for those who have not, is there anybody in the room who has not ever written a line of Terraform? Okay. I'm not going to ask that question. Let me just touch on the code really quick. Okay. So this directory in a version control repository, I think you guys use, or you all use Bitbucket Server. This is GitHub Enterprise. We support both. Everything that's in this directory, if you were to run Terraform plan, Terraform is going to read all of this stuff, anything that ends in a .tf, and it's going to create those resources. And that might be on Azure, that might be in AWS, it might be Google Compute, it might be all in the same workspace. But essentially what it's going to do is, Dale likes to use this analogy of it's going to build the city, meaning the roads, the electric lines, the buildings, etc. And then I know that you all use something like Ansible, and I like to use that as an analogy that Ansible is going to do all the interior decorating, but also install what's inside the buildings, etc. So actually, when people are looking to adopt infrastructure as code without adopting some kind of configuration management, we warn strongly against that. So usually we don't advise that you ditch one in favor of the other. But let me show you what it looks like a little bit. So this is what Terraform looks like. It can look simpler, it can look more complex, but let me just break down one particular resource. So we're creating a role up there. That's great. Let's focus on this one. So this is just an AWS launch configuration. I'm calling it HashiStack servers. We affectionately call the HashiStack a cluster of servers that are running Nomad, Console, and Vault. So internally, that's kind of what we call it. So we have an AMI that has all those, and then it clusters all of those together. But this is just a launch configuration. We're not giving it a public IP address and a number of other attributes. But all we're doing is saying we want one of these resources, and these are the things that we want to be true about this resource, and then Terraform will actually engage. You have to give Terraform credentials, but it will engage with AWS or Azure or whatever and create those resources for you. Just to kind of level set before we blaze ahead here. That's just kind of how it does. And there is an implicit relationship. So if you have a variable that is being created, if you create a resource and that resource has a name, and then you're later on in your config using the name of that resource, there's an implicit relationship set so that Terraform knows to create the first one, the one that's being consumed first. Okay. So if we go to do sort of the simplest, let me go to the organization here. If we want to create a new workspace, and Workspace is sort of a new technology that I'm not going to break down in detail here, but we're rolling it into, we've begun to use it more with the open source as well as the enterprise. But a workspace you can think of as an instance or a directory, an instance of a repository or a directory where you're running Terraform and it's creating a state and creating infrastructure. When you create it in Terraform Enterprise, you are giving it a name. And then at some point, you will have connected your Terraform Enterprise instance. And I want to pause here and just say, the architecture, just as a shorthand for what the architecture for Terraform Enterprise looks like, it's the only one of our 4 core products that wasn't kind of born as an API. So Vault is an API, Console is an API, or has an API, however you want to say it. And Nomad has an API. And this, Terraform, is obviously a CLI tool if you've ever used it. So we built an application that wraps it. You can think of it like Bitbucket Server or GitHub Enterprise as an application that wraps the core binary. Git and Terraform, both open source. Anybody can do anything they want with them. We've built an application to sort of enable collaboration and governance around that. And some of these concepts are going to seem really familiar to you because I know that you all have built some of these workflows on your own in-house here. So version control integration, you can tie this sort of instance. Think of this as like a Bitbucket Server instance. Or think of this as tied into your Bitbucket Server instance. When you go to create a workspace, it's going to tell you all of the, since there's an OAuth connection between Terraform Enterprise and your Bitbucket Server, it's going to tell you all the repositories that it knows about. So you can choose from that list of repositories and create a workspace. So a couple of things that you'll specify here are the working directory. In other words, what directory do you want Terraform to execute within? That's if you have a subdirectory like /production that has all your Terraform configs for production. Not that I recommend that pattern, but if you had that and then you had submodules that lived a couple of directories above it or one directory above it, you could say, yeah, execute in this directory, however, clone the whole repository because I need relative paths to my modules. So we can support that. The reason this is important is what's going to happen, and I'll show you this in just a moment, and then you can tie it to a default branch. It's going to choose the default branch of the repo, or you can specify what you want the default branch to be. This is important because Terraform is going to, as soon as you create this workspace, it's going to create a webhook on the repository so that all workspaces that are tied to that repository, when a change is made in that repository, will run a Terraform plan for testing purposes. And I'll show you some more things that are going to happen, but you don't have to do any of that. When you create a workspace, Terraform will handle that for you. If the push happens to, or a merge request happens on a branch that is not the default branch, you will not be allowed to run an apply. In other words, you can't apply that configuration and build those resources until you merge it into the branch that the workspace is tied to. This is pretty cool because if you think about, if you tie your dev workspace for your application to master, we're creating a promotion workflow so that you can have everybody pushing to master all the time with no risk to production, because then you can set the production workflow within the app to say promote this config to staging and now production, and you can have some level of comfort that that's never going to be promoted unattended, I should say. So I'm actually not going to create it. I'm a brave demo giver, but I'm not that brave. We could create the workspace, but I'm not going to use one that I create today. What I'm sitting in right now, the workspaces that you saw, let's just go back here. So this is an organization. Just like in GitHub, you have orgs with repositories underneath them. You have workspaces underneath the organization. So you might have a network organization, a number of different infrastructure teams. Each has their own organization. You have notably SAML authentication integration. You can use your GitHub authentication, et cetera, to give access and restrict access. But I have two workspaces here. One creates a Hashistack. The other one just creates a network topology into which I'm provisioning my Hashistack. So my cluster of Hashicorp servers, basically. If I go to the organization settings, there's a couple things I want to point out. First, we have the OAuth connection. So this is where that's configured. We also have just rolled out the, I don't have it configured here, but the capability to have an internal module registry. So if you have a bunch of internal modules that you want to expose to your users that never need to know about or write Terraform, they can click and choose things like VPCs and stuff within your established guardrails, and Terraform Enterprise will actually generate the config for them and save it, and they don't need to ever worry what the config looks like. They've just chosen the different modules for the infrastructure they need to create. Okay. SSH keys, that's for if you have a module. If you have a module, or sorry, a Terraform config, and you're invoking submodules from different repositories, you need to clone those. What's going to happen when you kick off a run is Terraform Enterprise is going to bring up a container, run a Terraform in it, and get all your dependencies. It's not going to be able to do that if you have submodules that require an SSH key to go get those submodules. So you can configure an SSH key on the organization so that you can access all of the submodules in your organization as well if you want. For those that haven't used Terraform, that you probably don't care at all. It's just a little bit of a complexity to call out for those that have. This is relatively new. So this is Sentinel Policy. This is enterprise only, but it's interesting because it's a problem that a lot of people have run across, and they've built varying things. In fact, I think you all have something on the radar to build something around this where you want to set conditions for all your Terraform repositories to say, if it does not meet these conditions, do not let it deploy. Okay? So this is our language, and we tried to make it as human readable as possible. But what's happening here is this is organization-wide. So every workspace that anybody creates here, and imagine some users may never log into this UI. They may trigger the API. You may have a Jenkins pipeline that's triggering this API. But everything that is created through this application or through this org, this will apply. So we're allowing some instance types, right? So every TF plan that happens, and you can't run an apply without running the plan first. Every TF plan that happens, there's this allowed instance types value, right? And what we're saying here is, for every resource that is an AWS instance, take its name and make sure that the instance, so the attribute, the instance type attribute is within the allowed instance types. So if I try to run a Terraform plan and somebody commits to a repository, to their Terraform config, and a plan automatically runs, you have a few options here. No matter what they write in their code, within this instance, obviously they could go off with their own credentials and do whatever they want if they have AWS credentials, right? But if everything's controlled through this funnel, you can do hard mandatory, meaning if you go outside of these instance types, you're simply going to block that from happening. The other one is allow people to override, but warn them first, and make them choose to override, or just advisory. Just say, hey, this is outside of this rule, but you can still deploy it. And that will be useful, obviously, if you want to track the trending of what's inside and outside of compliance. So I'm just going to do soft mandatory for now. I have already run this to create my sort of Hashistack. So what you can see here, I can see the last run. What I'm more interested in here is the runs that have been triggered. So you can see it was triggered by me in the UI, or this is my GitHub user. That's Zach Galifianakis, not me. But I'm the hob. So if I go in here, this is my repository. I'm just going to edit the README. We're not going to do anything exciting. If I commit these changes, I'm going to commit into a branch. Great. So what happens, because the webhooks are there, going to actually trigger some Terraform tests for me. And I can click on this. This will look familiar for anybody that's used like the GitLab or the Jenkins CI builder stuff. Just report directly back onto your pull requests. So it tells me here my plan happened. Great. Cool. And yeah, I think we're done here. Yeah, so I ran the update. There's no changes or anything like that. If there were a change, it would actually run my policy. So let's go back here for just a moment here. Okay, so here's where Sentinel runs. Okay, so it tells us every time a plan happens, it'll report back pass or fail. And it's saying that my policy restrict instance size is true, so I'm all good. This can actually be applied. So here, if I go ahead and merge this, and let's make sure that all my tests passed. There's the pull request, confirm the merge. Cool. And we should see another, if I don't have demo gremlins, we should see another plan kicked off here. But really nothing's going to happen. I'll grab the public IP address here and just call out a couple of pieces. Great, cool. Okay, so that's my last run. Everything looks good, great. So now, if I go to, so what I just deployed was, among other things, a Vault instance. How many of you actually worked with Vault before again? Okay, so Vault is our sort of secrets management tool. It sits in, this is not really a Vault demo. I'll show you a little bit about it, but Vault is traditional secrets management where people can store and retrieve secrets. There are dynamic secrets as well. So Vault can sit as an arbiter between your applications and things like MySQL or SSH. So in the case of Ansible, where you all use Ansible, Vault can facilitate in a couple of different ways. It can sign SSH certs, or it can issue one-time passwords. So it can sit as a privileged user between your users where they authenticate with Vault, issue a one-time password, and it sets a lease on those credentials. So it can then revoke those. Same thing with MySQL. So what happens is your application is quote-unquote born. Vault, it authenticates with Vault via a number of workflows that we have. It gets those credentials back. Every application instance might get different credentials, but what's happening behind the scenes is Vault is actually going and creating a grant and a user in MySQL or a number of other databases and setting a lease on that. And when those credentials expire, Vault will actually remove that grant and those credentials. And it's all audited in one central place. There's also, if you want to manage your certificate infrastructure, Vault has a PKI backend. So if you want to automatically issue certs, there's also transit, so you can encrypt. You can pass things through Vault to encrypt, or you can manage encryption key material that you may be uploading to KMS, et cetera. Manage the lifecycle, versioning keys, rewrapping keys, all that stuff. Just to show you a quick run through here, Vault, in order to store and access everything, it uses a master encryption key. It encrypts everything at rest. And so the idea here is there are ways to automate this using AWS KMS as well as hardware security modules. But when you first initialize Vault, in order to construct that master key so that Vault can do literally anything, retrieve and store, you set a number of key shares. So you might have 5 people on your infrastructure team, so you set 5 key shares. You can PGP encrypt each share, and the key threshold is 3. That means Vault needs 3 people to actually enter their key share before it will unseal itself. Operationally, this is really important because you don't want any one person to hold all the keys to your kingdom. So I'll go ahead and do that, and then we'll kind of stop for any questions. So I'll go ahead and initialize here. So this is the first time you initialize. It's going to give you all of your key shares. I would have PGP encrypted these in real life, but this is obviously not real life. Okay. So I go through the unseal process here. Continue to unseal. And then I'll use my root token to set some basic policy, maybe authentication, etc. And from there, I want to revoke the root token so that nobody has access to that root token anymore. Absolutely. It's an API, so everything that Vault does is in the API. Essentially the CLI, as well as the web UI. This is not going to let me bypass this, is it? I don't know why that's frozen, because demo gremlins. Here we go. Yeah, let's just grab this. Okay. Yeah, absolutely. So like I was saying, Vault is an API. I mean, it's consumable to be an API, which is actually really powerful when you think about pretty much any language, like your Java apps, Python, Ruby. They all have a concept of an HTTP request. So it's all a REST API. So if you want to be able to build encryption into your apps or anything like that, you can use HTTP. There is like Spring Vault, which is a Java SDK or Java framework to make your apps sort of Vault aware. We also have some tools so that you don't have to recode your apps. They will just make your apps aware via environment variables or config files of anything that's stored in Vault. So yes, you can do it from different machines. You can log into the web UI from anywhere that can access the web UI. And so you could have somebody in Singapore, somebody in the US, and somebody in the EU that has to actually enter their key from a separate location, and then it initializes Vault. The only way that we recommend automating that, if you need to have a self-sealing auto-scaling cluster, is storing that master key either in a hardware security module or using AWS KMS or a cloud HSM, which is the same thing as a hardware HSM, basically. So this is just kind of, I'm not going to get into the architecture, et cetera, but everything in Vault is on a path. So imagine that you had a path that was secret/ops, secret/dev. You could give people sandboxes where they can store and retrieve secrets in an automated way. But then when you're going into production hardening, maybe you have a few paths or a few clusters that are only accessible by a smaller group of people. Yeah, so what I've spun up is, just kind of show you with Terraform. It's, for those who have used Terraform for a long time, this isn't super impressive. However, it is the way that we'll run like a POC when we come in to help somebody understand Vault. We'll basically spin up this infrastructure. It's just 3 nodes running Vault and console. And then we also, let's see. Do the first thing you're not supposed to do. Become root. Nodes equal. Okay. Yeah, we're just going to leave that for now. What I was going to show you is the reason we run console is it's the highly available storage backend for Vault. There's one other one that we support, and that's DynamoDB. But it also helps in the leader election process, et cetera. It also registers Nomad, Vault, and console, and where they live, where those services can be found. And all the services on there can just query localhost on DNS to get those IP addresses, or you can query console via a really well-formed API as well and get things like milliseconds between nodes and all sorts of useful data around that. So I'm gonna pause there for any questions or anything else that anybody wants to know about. All right.
Dus.
Everybody else wants to know about beer and leaving. Is there anything, let me ask one question. Any of the workflows in Terraform Enterprise, I know that you guys have built a lot of infrastructure around Terraform Enterprise. So is there anything that sort of piqued your interest in terms of workflows that you think you either do better or that you've already built solutions for, anything like that? I was saying earlier with the team that I do interface with the Terraform teams. This is also a good chance for you to get your gripes out. If there are things about the product that you wish were a thing that are not a thing, or things that or just completely things that really drive you nuts. So features that don't exist or things that drive you nuts. I do take those back to the teams that build Terraform, console, Nomad, and Vault.
Yeah, I just have a much more general question. So in the beginning, you mentioned there, your colleague mentioned there, for each major cloud provider, there are lots of people working on the
Yeah, so I'll repeat the question. So do we know of successful use cases where people are truly failing over to a different cloud when something like AWS is down? The answer to your question is no. Most people are using this as an insurance policy that if they ever need to switch to another cloud, that the workflow remains the same. There are times where a certain component, what we see more often is people that have internal VMware deployments, where they have certain components that live on-prem and have to live on-prem. And then they have other components that live in the cloud, or they need to replicate a component like a Vault cluster or something else that lives on-prem, but they also need to create another one in the cloud. That's a far more common use case where people are deploying to OpenStack or VMware locally, and then they need to also have an instance of that in AWS. But no, the mythical we need to fail over like cloud broker conversation. And honestly, there are probably people within the org who have run across that, but I've heard that question before, and people try to sell based on that question sometimes, and it's not, I mean, we don't, but they try to like instill fear that what if it goes down? Well, it's not that trivial. I mean, you do need to have some, we did a demo at reInvent where we created the same infrastructure in Google Compute as we did on AWS, and we showed that when you were in the US, you were hitting Google Compute, and when you were in the EU, you were hitting AWS. But really, that's just to show that you can create both of those in the same config. And really, the more practical use case is people are using that for their on-prem cloud and AWS as they move to the cloud. That's a much more common use case, is they're using it as a transition step. Yeah. Thank you for asking a question. It makes me feel much better. I'm Chad at Hashicorp.com. So if you have other questions or gripes about the product or pet issues you've opened that Mitchell and Armon and Jeff Mitchell or anyone else have ignored, you can ping me on it and I can see if it's on the roadmap for you.